into a topic which no in the world knows. Even an infant baby itself knows. Pa, guess the topic. It's in, I think it's about in chemistry and physics. Papa, let's see who guessed it. Amazing, wonderful. It's correct. It's a matter. It's everything. Matter is around us. We are going to learn about matter.
Hi all, welcome back to the YouTube channel Allrounders. In today's video, I'm going to be talking about matter, which is a continuation of the last episode, which was done by Abhinav. I hope you check the video out in the link in the description below. Okay. So I'm going to be covering the topics for matter which Abhinav hasn't covered in his video. So it's still a continuation. So this is going to be the last part, and we are back from 1 month after posting since we had exam in this month. So I'm going to be giving you the starting kinetic molecular theory of matter to the law of conservation of mass of matter. So let's get into the PPT. So here is the PowerPoint presentation, and we're not going to be discussing much of topics, but but I'll try to make it short. So let's get into the first slide of this PPT. Learning objectives: kinetic molecular theory postulates heat transfer and law of conservation of mass. First subheading: kinetic molecular theory postulates. So it consists of composition of matter, intermolecular space, intermolecular force, kinetic energy of molecules, collision of molecules, and finally the movement of molecules in different states. So let's get into the first subtopic of the postulate. Composition of matter. Matter is made up of molecules. Molecules are made up of atoms. And finally, atoms are made as subatomic particles. Molecules of the given substances are identical. Example, molecules in water are identical in terms of their chemical properties. So I hope you understand on this. So let's get into the second one. Intermolecular space. These are empty spaces between molecules of matter. These are called intermolecular spaces. It gets larger when it changes from solid to liquid and gas. It's absent in solids, more compared to solids in liquids, and larger in gases. So Abhinav has explained most of these subtopics in his previous matter video. I'm just giving you a more of a brief and some extra information. Okay. So let's move on to the third. So next we can move on to intermolecular force of attraction. So attractive forces between molecules of a substance are intermolecular forces. The force becomes stronger as molecules are close together. It's strongest in solids, and in liquids it's not as strong as in solids, and it's the weakest in gases. So as you can see, the intermolecular force of attraction is much weak in gases. Liquids it's moderate, and in solids as you can see very much close together, very much tightly packed, very much close together. So let's move on to the next one. So in this we will be talking about something new: adhesive force and cohesive force. So the force of attraction between molecules of same kind is the cohesive force. Force of attraction between molecules of different kinds is adhesive force. So I'll give you one example for each. So for cohesive force, dewdrops forming a bigger one is cohesive force. For example, two water droplets, they combine together to form a bigger water droplet. They, that's the cohesive force between them. And next, for adhesive force, it's water particles clinging to glassware. So, glass is solid as we all know, and water is liquid. So pretty much both of them are different kinds. So we can call it adhesive force. So here's the picture here. So two water particles are combining each other. That's called the cohesive force. And this is some other substance which is they are like clinging to. So this is adhesive force. I marked it here notes. So next one, kinetic energy in the molecules. So molecules in matter are in constant motion. Due to this movement, they possess kinetic energy. It can change whenever it is heated or cooled. So it's less in the solids compared to fluids, which is the gas and liquids. So in this picture, I know it's kind of small for you guys to see the particles, but I hope it's comprehensible. So for solids, the particles are very much closer, so they vibrate about their position whenever they move, when they heat it. So next, whenever they heat it. Okay. So next is liquids and gases. They pretty much have like this kinetic motion. So you can say it's more in the fluids. Collision of molecules. So molecules of a substance collide with each other in gas. In gas and liquid state, the molecules also collide with the walls of the container in which they are kept. So collisions between molecules and container exerts pressure on the walls. So example, this is the container here. This black outline here. That's example. This is the container, and these are the molecules. So they keep on constantly move here and there, and they collide here and here and there. So that's the collision of molecules. Next let's move on to movement of molecules in different states. In solids, the molecules vibrate about their position. In liquids and gases, they move randomly in all directions. So as the temperature of substance increases, molecules move faster, and hence the kinetic energy increases. As temperature decreases, molecules move slowly and kinetic energy decreases. Pretty much you can understand from this picture and whatever I've told. So let's move on to the second subheading, heat transfer. So the modes of heat transfer are conduction, radiation, and finally convection, which also gives a bit of an info for convectional currents. So next, so let's go to the slide for conduction. Conduction is the process by which heat energy is transmitted through collisions between neighboring atoms or molecules. Conduction occurs more readily in solids and liquids, where the particles are closer together than in gases, where particles are further apart. So as you can see from this picture, there's a candle, and the flame is burning, and a person is keeping a metal rod or some other solid rod near the flame, where you see this part where the molecules are there, that they vibrate about their position. And and you might be wondering, what is this arrow mark for? So so like I said, it transmits their like vibrations to the end of this part of the atoms. So from this it gets heated, then from here and all it will get heated, then finally here it gets heated. So it transfers the energy, it transfers this vibrations to the end of the solid rod. So next one we'll be talking about radiation. So radiation is energy that comes from a source and travels through space at the speed of light. So this energy has an electric field and a magnetic field associated within it, and has a wave-like properties. You could also call radiation electromagnetic waves. So example, like I said, this is the source. This fire right here is the source, and it's like this is the energy it's sending, and it has an electric field and magnetic field associated, and has a wave like property. So as you can see, this arrow marks are wave like. So that's pretty much of radiation. I hope you can understand from whatever I said. So next one, convection. So convection is the process of heat transfer by the movement of molecules within fluids such as gases and liquids. As the fluid is heated, it becomes less dense and rises. The change in density is caused by the molecules of the fluid moving faster and further apart. The further apart the molecules are, the less dense the fluid will be, causing it to rise. So this picture shows convectional currents, like I said. So hot air rises, cold air comes down. So this cycle will rapidly keep repeating. So I'll give you a natural example for this. You can take sea breeze and land breeze, usually happening in the beach we usually visit. So pretty much you can understand from the diagram and what I said. Like, and next let's move on to the third subheading, which is law of the conservation of mass in chemical change. So this is for chemical change. I'll be talking about physical change later on. So law of conservation of mass states that in a chemical reaction, mass is neither created nor destroyed, but chemical composition only changes. For example, carbon atom in coal becomes carbon dioxide when it is burned, and the carbon atom changes from a solid structure to a gas, but its mass does not change. So now in physical change. Here when you heat or cool a state of matter, it changes into other state, but the mass does not change. For example, melting 100 grams of ice cubes changes into 100 grams of liquid water. Even when you vaporize liquid to gas, the mass does not change, and vice versa by cooling. So this is the diagram I've selected. So this is pretty much the flag end. So I hope you guys understood from whatever I've discussed from all of the subheadings, and this can be a helpful video for everybody, even for adults also, to make them understand even by now also. So that's it for this video, and thank you. Then please like, share, subscribe, and turn on the notification bell so that you don't miss whenever we post a new video. So thank you, and we will see you in the next video.